look at this question. 8 identical 20 by 30 inch. So we have 8, 1, 2, 3, 4, and we have 4 and 4, 8. 20 here and 30 here. 30 at the bottom and 20 here, the width. Inch, rectangular plates. So this is a rectangular plate, 20 by 30 inch, each weighing 50 pounds. So the weight of every rectangular plate is 50 pounds. And the 50 gonna be in the center. So this is the rectangle, the center gonna be in the middle here. Okay? So the weight is 50 pounds, are held in a vertical plane as shown. All connections consist of frictionless pin. Look at this. Here there's a pin, and here there's a tension. And sometimes you'll find a ruler. Here, ruler. See? This one has a ruler. So all connections consist of frictionless pin, ruler, or short links. For each case, determine whether the plate is completely, partially, or improbably constrained. The reactions are statistically determinate or indeterminate. The equilibrium of the plate can be maintained in the position shown. Okay, let's take it one by one. Remember, this one, there's a tension, there's a cable. If you just zoom in, there is a cable here. You can see it. This is the cable. This cable. And here there is a hinge. So here there is two forces, X, Y, and there is one force here, tension. Okay? So let's go ahead and see how could you solve this question. Okay, so there will be a tension here. Tension. And of course 20 by 30 inch. 20 by 30 inch and 50 pound. Remember, the 50 pound is at the center of the rectangle. This is the center, 50 pound down, following gravity. And at A, remember, there was a hinge. There is one reaction in the X and one reaction in the Y. There's two forces, one in the X, and I'm going to assume them all going to the positive X, positive Y at this point A. Let's find out some definitions. We should know that equilibrium is a state when all external forces acting on the rigid body form a system of forces equivalent to zero, which means summation of forces at X equal to zero and summation of forces at Y equal to zero. This is only at equilibrium. There will be no rotation or translation. The forces are referred as balanced because they have to be balanced, otherwise they are not at equilibrium. Remember, if there is a ruler like this prevents motion up and down. If you have a hinge like this prevents motion vertical and horizontal. This is up and down, going up and down. That's why you'll have a vertical force here. Here, vertical and horizontal, which means one reaction here and one reaction there. One reaction to X and one reaction to Y. If you have something like this, it's not only one reaction to Y and one reaction to X, also there is a moment because it will prevent rotation. Okay? One definition, what is the meaning of completely constrained rigid body? Which means that you have the same number of unknowns reactions as the number of equilibrium equations. We have three equilibrium equations: summation of forces at X equal to 0, summation of forces of Y equal to 0, and summation of moment. So there is three equations. But if we have three unknowns, it's a completely constrained. Okay? And cannot move under the loading condition. The reactions are statistically determinate. If we have three unknowns, and of course, we always have three equations. Statistically indeterminate, what's the meaning of that? When you have a rigid body, when there are more unknown reaction, you have four unknowns, than the number of equilibrium equations. The reactions that cannot be solved for a statistically are called statically indeterminate. Not statistically, sorry, statically. Okay, let's look at this. First of all, let's look at the graph. How many unknowns we have? Remember, before we start this, we have three equations. We have summation of force of x equal to 0, we have summation of force of y equal to 0, and we have summation of moment equal to 0. Here we have one unknown, the tension, and we have ax, ay. So you have 1, 2, 3 unknowns. We have 3 unknowns and we have 3 equations. What's the meaning of that now? Now this is not unknown, this is known. 50 pounds is known. The weight of the rectangular is known. So the answer for this, since we have 3 equations and 3 unknown, is completely constrained. The body is at static conditions. And there are only 3 unknowns, so the reaction is determinant because we have 3 unknowns. And the plate is in equilibrium. Let's take moment at A. Let's take moment at A. Moment at A to cancel out AX and AY. Let's make a nail here. And this 50 pound down, it will rotate in the negative. See, this will push the whole plate around the action. If you make a nail, this weight will move the whole plate that way, clockwise. So 50 times, what is the center of this? Since this is in the center of the plate, we know it's 30 inch. So minus 50 times 15. Okay? Minus 50 times 15. And this one, reaction C, will pull the whole plate counterclockwise. And we have to know the vertical distance is 30. So C times 30 and minus 50 times 15. So minus 50 times 15 and C plus C times 30 equal to 0. And that would give you C is equal 25 pound. Because if you take this one the opposite side, C is equal to 30, you put it there, 30 and 15 is 2 down, and okay, C is equal to 25 pounds. Now what is the next equation? Summation of forces in the Y. Remember, there is one force in the Y, let's see it. One force in the Y, C, plus AY minus 50. C plus AY minus 50. So C plus AY minus 50 equal to 0. Now we know C here, 25. So 25 minus 50 is minus 25. You take it the other side. AY is equal to 25 pounds. So now we find AY. Let's find the third equation, summation of forces of X equal to 0. So we could see that there is nothing in the X except the AX. So summation of force equal to 0. AX is equal to 0 because there is nothing else is in the X direction except AX. Which means that A, if you do AX square plus AY square all under the square root, will give you that reaction at A is 25 pound. Okay? And of course it's in the y-axis. Okay, let's look at the second question. Now, let's go to the question itself and see it. Look at it. Look at it. Number 2, we have tension, and we have tension. So we have 3 unknowns. 1, 2, 3. Tension is only one force. Okay? So you have 3 forces, and they are all, look at this. Tension in the D, tension at the C, tension at the B. Now we have how many? We have 3 unknowns. And we have, of course, 3 equations. So what's the answer to this? Well, if you have 3 unknowns and you have 3 equations, it is completely constrained, that's for sure. And the reactions are determinant, for sure. And the system should be in equilibrium. Let's find summation of force at X equal to 0. Remember here, this is the only, this is in the y, this is in the y, this is in the y, this is the only in the x, b. So summation of forces at x equal to 0, b will equal to 0. Okay, b is equal to 0 because summation of forces at x equal to 0. Now, let's do summation of forces at y equal to 0. You have c plus d minus 50. C plus d minus 50 is the answer, and that is summation of forces equal to y. C plus d equal to 50. Don't worry about the last one is wrong. So C plus D equal to 50, and that's it. There is nothing else. You cannot solve C and D anymore. Okay? If you want to find summation of moment, let's look at summation of moment, if that's going to help. Now we know B, so we don't have to take B. We know B. We don't have to take it. Let's take moment at C. Okay? Moment at C, we know that this is 0. Ignore it. Now we have D. D times what? D times 30. And that is going to be in the negative. If you have a nail here, this is going to go in the negative. So minus D times 30. And this one will push it that way, counterclockwise. Minus D times 30 plus 50 times 15. Okay? 50 times 15 in one side equal D times 30 in one side. 50 times 15 and D times 30. D times 30 and 50 times 15. So 15 over 30, 2 is down, 50, 25. So D is equal to 25. So D is equal to 25. So D is equal to 25. So which means that C is equal to 25. This is wrong. This should not be done here. Okay? So I'll try to do this question because this was solved wrong in the solution. Because here he did summation of force at x equal to 0, b equal to 0. Summation of force at y equal to 0. This is it. And then when you do summation of moment, D will be equal to 25 once you do summation of moment. And then you could find okay, let's start this question one more time because there was an not complete answer, but I'll try to redo it again. Again, you have one tension in the C, one tension at the D, and one tension at the B. You can see it over there. One here, and one here, and 20 inch, 23 inch, and 50 pounds. It's the weight in the center. You have three equations, and of course, three unknowns according to C. So it's completely constrained because three equations, three unknowns. The reaction determined because you can solve for the reactions. The system is in equilibrium, summation of force at x equal to 0. So there is no force in the x except the b. So the b equal to 0. And then when you do, let's see this. When you do summation of force at the y equal to 0, you will get C you can see C plus D minus 50 equal to 0. So C plus D equal to 50. So you can see it's C plus D equal to 50. That is summation force of the y. Now, the third equation is summation of moment. Let's take any location. Of course, now we know that this is 0. This one is 0. So you don't have to take moment at this point because it's not going to help you. This is 0. Let's take moment at either C or D. I'll choose D. I'll put a nail here, and I will see that this tension will pull the rectangular that way. This tension will pull the rectangular that way, counterclockwise. It is positive. So C times 30, and of course C and the perpendicular distance is 30 inch. C times the perpendicular distance, the distance 30 inch. Okay, This is the perpendicular distance. So c times 30. C times 30. And let's look for the other one. There's a force in the y, 50, and it's going down. And if there is a nail here, this force, the weight of the rectangular, will pull the whole plate clockwise around D. And this is the perpendicular distance. This is 30. That's going to be 15 because it's going to be in the center. So minus 15 times 50 equal to 0. You resolve for this. C is equal to 25 pound. So C is equal to 25 pound. Remember this equation, C plus D equal to 50? You put 25, C is equal to 25, and D is equal to 25 pound. So we found B equal to 0. C is equal to 25, and D is equal to 25. Let's look at the next question. This one. Number 3. You'll have a hinge and a hinge. You'll have two reactions here, AX, AY, or this is point D. So you can have dx, dy, and you have ax, ay. So there's now this is four unknowns. Dx, dy, and ax, ay, that's four unknowns, and we have only three equations. So what will be the answer for this? Okay, so let's go down to the third one. You'll have dx, dy, you can see it here. And you have ax, ay, and 50 pounds is always in because this is the weight. What is the meaning of this? Four equations and we have three unknowns. We could call this, it's completely constrained. There are four unknowns, so the reactions are indeterminate. That is the next one. It's not determinate anymore. It's indeterminate. So let's find the blank is in equilibrium, the plate is in equilibrium, and find the summation of moment at A. Let's take summation of moment. Either you take it at A or at D. At A, if you take it moment at A, remember, dy, it's in the line of the action. So this, you will not, there's no perpendicular distance between A and D. So this will go. dx is the only one in the moment going to be summation moment at A. dx, and this is going to push the plate clockwise. So dx times the perpendicular distance between A and D, 20 inch, dx times 20. And this is also going to push it the negative way too, 50 times 15. So 50 times 15 and dx times 20. This is summation of moment at A. Okay, so the question going to be, they're both going to be clockwise, so it's going to be minus dx times 20, minus 50 times 15 equal to 0. Okay, you find the answer going to be dx is equal minus 37.5 pound. Remember, dx was in what direction? We assume it, and it's a minus, going to be the opposite way. Okay, so dx is equal to 37.5 pound, and we assume it positive, but it's going to be negative, so this is wrong. So it's dx is 37.5, and this direction should not be there. This is going to be for the positive. It's going to be the negative x. So this direction is wrong. Now, we found summation of moment at A. Let's find summation of moment at B and see what will happen. Or, sometimes you have dx. We could find ax because summation force at x, it's either dx or ax. There's nothing else in the ax, so if dx is that way, this is going to be the opposite of that. So if this is going to go to the negative x, this is going to be going to the positive x. It's going to be the same number. But let's find summation of moment at D because the vertical are the one that we will have a hard time with. So summation of forces at D, this is going to give you another. I'll do this one more time. If you look at the things, summation of moment at A equal to 0. We did the same thing, and dx would be equal to 37.5 negative bound. I assumed that here dx is positive, so the actual dx direction is 37.5 pound and it's in the negative direction. And afterward, if you find dx, we could find ax, because summation of force at ax equal to 0, dx plus ax equal to 0. So summation of force at x equal to 0, dx plus ax equal to 0. dx we find it minus 37.5, so you put minus 37.5 plus ax equal to 0. Ax will give you 37.5 pound plus, which means that we assumed it positive and it is still in the positive direction. Let's find summation of force at the y equal to 0. We find ay minus dy. You could do it either the minus or the plus. Minus 50 equal to 0, minus 50. So ay minus dy minus 50 equal to 0. And by this, we can't find ay or dy. That's why this this problem is indeterminate. You cannot solve ax, or you can't find ay or dy. Okay, so this is an indeterminate. Now let's look for the fourth one. The fourth one, let's look at the question. Fourth one, look at it. We have one tension, and here there's a hint. There's two reactions. This is d, dx dy, and here there's a tension in the C. Let's look at this solution. So there is three unknowns, one reaction in the x and the tension, and two in the d, and there's one weight. So three equations, three unknown, that's fine. So this is completely constrained, but the problem here, it's indeterminate. Why? Because let's start by taking moment at point D. If you take moment at point D, this force is in the direction of point D, and there is no perpendicular distance between this tension at point D. There's a horizontal, and we don't take horizontal distance for moment. So summation moment at D, everything will vanish. This and this and this. The only thing is here is 50 pounds, and that's not gonna work. So summation moment will not work, and that's why this is indeterminate. So you could do it like that. It's an improbably constrained, indeterminate, and not in equilibrium. When we will take the moment at point D, the moment of all reaction vanishes. Let's look at number 5. Let's look at number 5. 5. You will see here, this D is one tension, and this C is one tension. So you have two unknowns, and you'll have three equations. Two unknowns and three equations. Okay. Two unknowns. Look at that. You'll have two unknowns and you have three equations. If you take summation of forces of the x, C plus D equal 50. If you have summation of moment at D, you could find, well, this is well-established equation, and you could assume it's completely constrained, the reactions are determinate, and the system are in equilibrium. If you take summation moment at D, you will get C is equal to 25. So summation moment at D, summation moment at here, C times 30 in the plus, minus 50 times 15. And you could find D in the y-axis, or in the tension. So summation of moment at D, you could find C is equal to 25, and summation of forces at the y equal to 0. Summation of forces at the y equal to 0. C plus D equal to 50. And let's take summation of moment at C. Summation of moment at C, it will give you, let's see, because this is also not complete. Summation of moment at C equal to 0. Let's see, a nail here, D will move in the negative, minus D times 30, minus D times 30, and also this 15, gonna pull it in the positive, plus 50 times 15 equal to 0. So d 30 equal 15 times 50 times 15, 30, 15, that's over 2, so d is equal to 25. So if d equal to 25, c is equal to 25. That's from summation of moment equal to 0. So this one, c is equal to 25, d is equal to 25, and b is equal to 0. Because there's nothing in the x-axis. Okay, that's not the one. We are in number. So c is equal to 25, and c plus d equal to 50, and d is equal to 25, and c is equal to 25 too. Let's look at number 6. Number 6 is, here you'll have 2 unknowns here, and you'll have 1 unknown here in the tension. So there's 3 unknowns and 3 equations. Three unknowns. If you take moment at this point, you could find B. And if you take summation of forces at the x, you could find dx because this is known. If you find summation of forces at the y, you could find dy because there is a force here. So completely constrained, the reactions are determinant. The plate is at equilibrium, summation moment at d, you could find b. Summation forces at x, you could find dx. And remember that if it's negative, it should not be this, it should be the opposite. This is going to be, we are always assume it positive, so it's going to be this is not the direction. And summation forces at the y equal to 0. And since it's minus, look at, this is correct now. Minus 50 pounds and it's down. It's going to be up because it's a minus. And since we have dx and dy, you should find the square plus square over all under the square root. D is equal to 62.5 pound. And you could find the angle by dividing fy or dy over dx, tan inverse. You could find the angle for that, 53.13. Okay, this is, let's go to number 7. Let's go to number 7. Number 7 is, one unknown, 2 unknowns, and 3 equations. So what is, if you have 2 unknowns, look at this, one in the d, and one in the y, and one in the a, they're both in the x-axis. The weight is like that way, and that's it. If you take summation moment at this point, you could find a. Okay? If you take summation moment at this, you could find d. Well, this is easy. You could find everything. So, but the problem is, this is improperly constrained, and the reaction are indeterminate. The system is not at equilibrium, as there is no vertical reaction to counterbalance the weight, the load of weight. Remember, we could find moment at this point, and we could find A. We could find moment here, we could find D. But there is no vertical reaction in the y-axis that will counterbalance the load W. So this is an indeterminate reaction, and it's improperly constrained. Let's look at the last one. Here we have, look at this, hinge, 2 reactions, tension 1. And here there's a ruler. This is a ruler. 1 reaction the y. So 1, 2, 3, 4. We have 4 unknowns, and there is 3 equations available for us. So let's look at the last one. dx dy, and we have b, and we have this. We have a tension here at c. Now, we could find summation of moment at d. This is going to be gone. You could find b. Easy. And then once you find b, what other reaction in the y-axis is this one, unknown. Summation force at the y, you could find dy, knowing that this is the weight too. Now we have two x's. Summation of forces for the x. Well, you could take moment at this point. You cannot find summation force of the x equal to anything. You cannot get anything out of this in summation force of the x. So let's do, it is an improbably constraint and determinant. The system is in equilibrium. Summation of moment at D is equal to 0. You could find B, of course. So if you take moment at D, at here, you could find B. This will be cancelling out. And then you find By or B reaction. It's 25 pound. Since we find summation of forces at the Y, we know this is 25 and this is 50. So this is going to be 25 up. So 25 up. Dy is 25 and up. So Dy 25 and up. This is correct. Now look at this. My 25 pound down and 25 up. For the other one, summation of forces at the x, you cannot find any answer for that. And this is going to be the end of question number 1.